I record and minimize this thing. Yep, I got lots of time on Thursday available. My Wednesday is already booked up, but are you going to have time Thursday morning or something? Isn't your final Thursday? Okay, well, I might be able to find a half an hour tomorrow, or I could find time early tomorrow. But tomorrow's not looking good. So let's see what we can get done tonight. Okay. Okay. It's time for you to be doing most of these problems, not me, especially since your test is coming up. So you tell me how you're going to do this. Excuse me. Excuse me. I think I covered the speaker up. Or the microphone, I should say. Okay, so first of all, you have to ask yourself, what method are you going to use? No, unless it says specifically U-Substitution. Okay. If you're going to use substitution, you got to get one of the equations solved for one variable. Which is the easiest one to do that with? And it doesn't matter whether you solve it for y or for x. You just have to solve it for one variable. How many steps would it take to solve that for x? Nope. 1. How do you solve that for x? Hold on a second. Hold on. We're talking about equation number 1 only. You have to solve this for x. If we could use elimination, yeah, the problem would be a piece of cake would have been done 5 minutes ago. But since they said use substitution, you got to get one of these equations in terms of one variable equals something. Come on, solve number 1 for x. Very, very simple algebra problem. Okay, so what's x equal to? All right. So we're going to cross this one out. There's our other equation. Now what are we going to do? What's the technique called? What technique do they want you to use to solve this? Okay, so what are you going to do? You got to be more specific. I don't know what that means. Tell me what you're going to substitute. So tell me what to write. That's the best way. Okay. Keep going. Okay. Now notice what you have. One equation, one unknown. Very easy to solve. What's the next step? Next line. Hold on a second. -10 minus 6y minus 3y equals 8. Okay. Okay, read the next line to me. Okay. Y equals what? Okay. Are you done with the problem? No, you're not. You got to solve for both variables. So now what? Nah, plug it into the easy one. This is much easier. So all you got to do is plug in y and you'll have x. This one over here, you're going to have to do a lot of math if you plug in y. So use the simplest one you can to solve for the other variable. No, this one over here. You've solved for y. What is x? You can write it piece by piece. You don't need to come up with a single number. Just substitute it. Well, I don't know. I haven't solved it. I'm going to do it like this. Minus 3 times minus 2. I always do that step because I'm looking at 3 minus signs. You try to do that all in your head, you're going to frequently make a mistake. But you're right. X equals 1. So x equal 1, y equal minus 2, you're done. Okay, now, notice how much easier x plus 3y equals 5. X plus 3y equals minus 5, right? Yeah. Notice how much easier, how hard it was to use substitution, first of all. Right? I mean, I've got a whole page here full. Okay. Notice how easy it's going to be to use elimination because they're both in standard format. When you have them in standard format, which is all the x's and y's on the left side, everything else, the numbers are on the right side, well, how can I eliminate a variable really easily? One step. What can you do to equations? Can you add them? Can I add equation number 1 to equation 2? Yes, you can. If I have a plus b equals c, and then I have x plus y equals z, I can add those two equations. So a plus b plus x plus y equals c plus z. You can also subtract. That's the key of elimination, is the fact that you can add or subtract any two equations. Any two. As long as they're part of a system. In other words, as long as my this x is the same as that x, and this y is the same as that y. So add them. See what happens. Good things happen. You got to add everything. You got to add the left side, and then you got to add the right side. Okay? Notice how much easier that was? It was one step, basically. And now I'm going to go into this equation and plug in x equal 1. So I got 1 plus 3y equals minus 5. 3y equals minus 6, y equals minus 2. Half a page of writing. So it's kind of cruel that they would give you these two equations and then ask you to do it by substitution, because it so clearly is easier to do by elimination. But that's okay. They're trying to accomplish something. I'm not sure what, but I guess they're trying to show you that you can take any two equations and solve them by either method. And they're trying to show you that there are some methods that are a lot easier. In other words, one is frequently much easier than the other. All right, what do you got next? Should I check my email? Is there still an email coming? Let me check my email. I'll tell you in a second if I've gotten it. No, have not. So it's not going out on your end. I can only guess maybe GoToMeeting is quite a hog. Hogs your resources, not only your internet but your computer. So it might be having some problems sending the picture out while you're on the GoToMeeting with me. In the future, try to send them before you start the meeting. Oh, you had too many of them at once. Yeah, you had too many of them on there. Yeah, I've tried to send like 8 pictures, and it never gets there. Seriously, I've taken 8 pictures and tried to send it up to my computer, and it never gets there. So there is a limit as to how many pictures you can attach on there. And it may not let you send another one out until it deals with that one. So I don't know if you have a way of deleting that one that you tried to send and then start over again. It might be the way to do it. But if all you're dealing with are problems like we just dealt with, you can verbalize those as easy as I can read them. So what else you got? Okay. Okay. Ideal for elimination, because both of them are in standard format. Tell me what we're going to do. You got to eliminate a variable. If I add or subtract these equations as they are, there's no variable that's going to get eliminated. I'm going to have x's and y's. I got to get these equations into a state where either adding or subtracting the equations will eliminate a variable. What can I do to do that? This is equation 1, that's equation 2. Okay. Of what? Well, which one? Matters. Okay, good. I'll multiply both sides by -2. You have to do both sides. Don't make a mistake and just do one side. It won't come out right. So that gives me minus 4x plus 16y equals minus 12. Now I'm going to cross that one out just because it's confusing when I have lots of equations up there, and I want to look at just the 2 equations. So now what? Oh, you know, where do you get -2y? You set it up so that you could add, that you wouldn't have to subtract. In other words, you could have multiplied both sides by just 2 instead of -2. And then we would have had a 4x instead of a -4x. And you could have subtracted the 2 equations. But I like what you did. You multiplied by -2 because addition is easier than subtraction. So now we can add equation 1 to equation 2. What do you get? Hold on, not 22. Okay. So y is equal to, okay. Now, part of the problem with crossing out that middle equation is that's frequently the one I would like to use to solve for x, because it's the smallest one. I can still use it, even though I crossed it out. I can still use it. And I'm going to use just this part of it. I'm not going to use it after I multiplied it by 2. That would be the equation 2 down here. But I'm going to use this one. 2x minus 8y equals 6. That's got the smallest numbers of any of the 3 equations and will be the easiest to solve for x. So, tell me what to do. Okay, tell me what to write. And that's always the way to do it. Do not do these in your head because it's really easy to get the sign wrong. Okay? So, now keep going. Keep going. Okay. Yep. That's the whole process. In a nutshell, is you have to, when they give you 2 equations where one of them has to be manipulated, sometimes both of them have to be manipulated. You don't want to use fractions. In other words, you never want to multiply one of these equations by a fraction. Okay? You might have something like this. Let me write it. All right, what would you do here? Solve this by elimination. How would you do it? It helps to number them like that, incidentally, especially when you have a lot. This one's going to give us a lot because I got to manipulate both equations. In other words, there's nothing I can multiply one of the equations by that's not a fraction where I'll be able to eliminate a variable. Can't do it. But I can multiply number 1 by something and number 2 by something else. That's always allowed. You can always take any equation and multiply the left side by the same thing as the right, whether it's in a system of equations or an equation all on its own. So what can I multiply 1 and 2 by so that I'll be able to eliminate, let's say, x? Perfect. Now tell me what my new equations are, 1 and 2. Okay. Yeah, don't say the plus and the negative. Okay. Now what? Okay. Keep going. You haven't solved for y yet. No, you've solved for negative y. You got to solve for y. Okay. You divide by negative 1, not negative y. You divide by negative 1. Okay. Now, which equation are you going to use? I didn't cross them out this time. Which equation has the smallest numbers to figure out x? Of all the ones, I'm looking at 4 equations there. Which one, starting at the top, has the smallest numbers? Okay, that one right there. So let's use that one. 2x plus 5y equals 7. Notice I'm using the part before we multiply by minus 3. Okay. Now what? What's the next line? Okay, that's one time where I can make a shortcut. Okay. Now, if your life depended on it, you'd go back and check these solutions. In other words, if x is 1, that's 3, that's 7. 3 plus 7 equals 10, so that works. 2 plus 5 equals 7, that works. So we've checked both of them, they both work. If you're taking a test, you don't always have time to go back and check. If time is a factor, you know, we've worked together for a while now and we've never made time a factor. But when you're taking a final, you do have a limited amount of time, don't you? So speed is a factor now. And the one thing you can do to make sure you stay on proper pace is to just be very, very diligent in your math so you don't have to check. In other words, if I'm taking the test and I get x equal 1, y equal 1, I'm going to the next problem. I'm not going to go check and make sure both solutions fit both equations. Only because it takes too much time. And now if you have time, if you finish the test and there's a half hour to go, then yeah, it couldn't hurt you to go back and try some of these problems. But I suspect that's not what happens. All right, what else you got? Okay. Okay. What's your first step here? This is your clue right there. They have not taught you how to factor 5th degree polynomials, except by one method. What's the only thing you can do here? Quadratics work on quadratics. This is not a quadratic. The quadratic formula works on a quadratic. This is a quint equation. This is a 5th degree equation. So you can't use the quadratic formula. There are not very many easy ways to do it, but there's always a first step. When they give you a factoring problem, always do the first step, greatest common factor. Don't try to factor immediately. See if you can do a greatest common factor. Okay? Is there a greatest common number that you can factor out of those? What's the biggest number that divides into 56, 42, and 35? Consider 35. What are the factors of 35? Times. Okay. Yeah, no, that's correct. Yes, 5 times 7 is 35. Okay. Now, see if either 5 or 7 divides evenly into these other two big numbers. Does it? It definitely does. So I'm saying 7 is the biggest one. So factor out a 7. What does that leave you? Okay. Now, can I factor an even larger number? Could I have factored a larger number out of there? In other words, if 7 was not the biggest, then I'll still be able to take another one out. And I can't. 6 and 8 aren't divisible by 5. So I took the largest one out because what I'm left with, I can't do anything with. However, I only took the largest number as a greatest common factor. What else can I take out? Variables count also. Is there a z that divides into all 3 terms? It's the maximum z, power of z, that divides into all 3 terms in the parentheses. Can I take a z out? Okay, then let's do it. Instead of 7, I'm going to take a 7z out. Now what do I have? This time put it in order of the degree. So put this term first. No. First of all, there's still a 5. And if I have taken a z out, then it's no longer to the 5th, it's to the 4th. Right? 7z times minus 5z to the 4th is what we started with. Minus 35z to the 5th. Okay, what's the next term? This one here. We finished the first term. It's minus 5z to the 4th. What's the next term? And the last term. Now, if you want to know whether that's correct or not, multiply them all back together again. You get this up here. You get 35z to the 5th, you get 42z squared, you get 56z. Okay? Now, that's all that they've taught you to do. We can't do anymore. We don't know how to factor that. I don't know how to factor that. So presumably they gave you this problem with the goal being you getting to this step. And then there's really nowhere to go after that. That's factored as much as it can be factored. Well, I don't really know that. There may be a factor of what's in the parentheses, but I don't know how to do it. I'd have to go to Wolfram Alpha, and I don't know any teacher that knows how to do it. So they don't intend for you to do it, clearly. Okay? All right, what else? Okay. I'm sorry, x squared minus 25? Okay. Always start there. Can we do a greatest common factor? What's the next thing we look for when you're looking to factor something? It's just there's exactly dopes. Difference of perfect squares. Dopes. Okay? Is this the difference of perfect squares? Is x squared a perfect square? Is 225 a perfect square? Are they being subtracted? Then you have difference of perfect squares. You have all 3 letters. So we can factor. How does it factor? Take the square root of both sides. What's the square root of x squared? What's the square root of 225? It's 15. It's 15. I don't expect you to know that. But now what's the next term? In other words, when you factor a difference of perfect squares, your job is to get the first term only. The next term takes care of itself. What is the next term? Always. Just the conjugate. Whatever the conjugate is. In other words, same two terms, different sign. Okay? So that's factored. You're done with this problem. Unless they said make it an equation and solve for x, now we'd have to set each of these equal to 0, and we get x equal 15 or x equal minus 15. But if the problem was just that, and they just said factor that expression, then that is the solution right there. We factored. But these steps over here, the third one is regular factoring. In other words, when you have an x squared and an x and a number, you can do regular factoring on it. If that fails, the fourth step is the quadratic formula. So you want to memorize these 4 steps, and that's always the order you go in. Always. A lot of times you got to get the greatest common factor out of there before you can even do that third step, factoring it, or a difference of perfect squares even. In other words, had they given us this problem, 2x squared minus 450, now that's no longer a difference of perfect squares, right? 2x squared is not a perfect square, nor is 450. But if I factor a 2 out, in other words, if I do step 1 first, then I get this, 2 times x squared minus 225, and now I know how to factor that. That's difference of perfect squares. So a lot of times you have to do that greatest common factor. You always want to be looking for it, always. 100% of the time, look for greatest common factor. If there isn't any, it shows up pretty quickly. I mean, it's not that hard to see whether there is one or there isn't once you get used to it. Okay, so what else? Okay. They better stop there. You don't know how to do that. Well, go ahead. I'll write it out anyway. Go ahead. See, if you stop there, you could factor out, the greatest common factor would be x cubed, and then you'd be left with a quadratic. In other words, when you factor out an x cubed, you're left with an x squared minus an x minus a number. That's why I said you better stop there, but go ahead, finish it. Okay. There's no greatest common factor. And the reason I know instantly is because this is a 1 right here. Okay? So there's obviously no number that divides into all of these numbers. And there's no x that divides into every term because this term doesn't have an x. So there's no greatest common factor for this one. The only way to do this one is on a calculator. Now, seriously, you could take this to your top math teacher at any high school in Denver, and they're not going to be able to do that manually. Serious. They haven't taught you how to do it, and it's enormously difficult. enormously. It's enormously difficult if it's a cubic, let alone a quintic. I don't know why they're giving you these kind of problems. I'm not sure what their purpose is. You should be working on factoring quadratics, to be honest. Having you spend your time working on fifth degree equations is really a complete waste of time. The only thing you can do with this is enter it into your calculator and then find all 5 zeros. Why do I know there's going to be 5 of them? Because it's a fifth degree polynomial. So you put it into your calculator and it's going to have something like that. In other words, it's going to have 4 extrema. Always one less than the degree of your polynomial. So if you put this into your calculator, graph it, and then you have to use your trace function to find those 5 zeros, and those are your answers. Now, you may not have 5 real zeros. You may have 3 real zeros and 2 imaginary zeros. We don't know. I have no idea. Without putting it into, I can put it into Wolfram Alpha and graph it. And the beauty of Wolfram Alpha is it gives you the zeros. You don't have to do that nonsense where you put it on trace, which takes forever. If you had this fifth degree equation, even with your, what kind of calculator do you have? Yeah, with the TI-84, it would take you a long time to do that. Not only do you have to input it in, but then you have to put a trace, and you have to go on one side and then the other, and it tells you where the 0 is. And then you do it for every point. One side, the other, it tells you where the 0 is. You do that 5 times. So this is a crazy, ridiculous problem that doesn't really teach you anything. When you have to use the calculator to solve it, it's not that instructional. Okay? We got 15 minutes. Unfortunately, I do have a 7:30 tonight, so I'm going to have to go at 7:30. But all right. I'm going to use, can you use any method you want? Or do you have to use substitution? You can use elimination. I'm going to use elimination because all 3 equations are in standard format. Okay? And whenever you're solving 3 equations with 3 unknowns like this, definitely number them because you're going to end up with equations all over the page. In fact, I'm going to have to start writing smaller. Okay? Now, the goal here is to take 2 of these equations and eliminate a variable. Do whatever you have to do to eliminate a variable. Okay? And then take any other 2 and eliminate the same variable. So that you end up with equations 4 and 5 that only have 2 variables in them because you've eliminated a variable. So let's pick a variable to eliminate. What's a good one that's already missing from equation 3? Okay, so let's figure out how to eliminate z. Which 2 equations are going to use? No, we're going to use elimination. You're going to eliminate z. Which two equations are you going to use to eliminate z? 1 and 2, 1 and 3, or 2 and 3? Those are your choices. Which two equations are you going to use? It's already missing from 3. And I kind of hate that they gave you the problem like that because it actually makes it more confusing. It's actually it's a simpler problem if you have all 3 variables in all 3 equations. But nonetheless, once you get used to doing it, it's not simpler. But if you don't know what you're doing, it is simpler. It's confusing when there's a variable missing from 2 of the equations. So I'm trying to eliminate z. So how about we use equations 1 and 2? So how am I going to eliminate z using equations 1 and 2? By positive 7, okay. Which turns it into 35x plus 7y minus 7z equals 98. This time I am definitely crossing it out because I'm going to end up with so many equations I got to keep them straight. Now, how are we going to eliminate z? You add which equation to which equation? Use my numbers over here on the left. Okay, what do you get? $125. Okay, now that is called equation 4. The basic concept when you're doing 3 equations and 3 unknowns is to create an equation 4 and an equation 5 that have the same 2 variables. Well, we don't have to try to eliminate z. We already have an equation 3 that is missing z, so let's just use it. Now we have turned the problem from 3 variables with 3 equations into 2 variables and 2 equations. We know how to handle these, right? We've been doing it all day. So let's solve for x and y using equations 4 and 5. So how am I going to do that? It's the simplest way. It'd be nice if I could multiply 4 times something to make it 35, but I can't. So eliminate y. How are you going to eliminate y? Be specific. When I ask a question, tell me exactly what you're going to do. Equation 4. Okay, so now I'm going up here to rewrite my equation 4. So 6 times 35 is 210. So that's 210x plus 30y equals 750. And the new equation 5 is, we're multiplied it by minus 5, right? So we get 20x minus 30y equals minus 60. Now we are in business. Now we can eliminate it down to one variable. What's the next thing I got to do? Okay, it's not 220. 210 plus 20 is what? It's a nice round number. It's 3. Okay. Now, so we've solved one variable. And now you got to work your way back. Okay? Now we got to solve for the next variable. Either y or z, it does not matter. We've solved for x, and I have this equation up here where I should easily be able to solve for y. Right? Okay, so tell me how to do it. Using this equation, solve for y. No, equation number 3. Okay. 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 24, you got to add 12 to both sides. Okay. Now we've solved for 2 variables. Now we still got to solve for z. Well, I got all kinds of equations up here I can use to solve for z. I'm going to take the original number 2, which says minus 2y plus 7z equals 27. So use that one to solve for z. Okay, so that's minus 8 plus 7z equals 27. So what do we got? 7z equals what? Nope. Those are the kind of mistakes you can't make, Brandon. Huh? 35. Use your calculator if you have to. I mean, but this one single problem, we're doing, what, 25 different calculations? If you miss one of those 25, you get the wrong answer. You lose all credit. So you have to be perfect on this arithmetic stuff. And I mean that. That's more important than anything else. I'd rather you not learn anything else here, but get your arithmetic right. Because what I would really hate to see is you to take your test and you're doing everything right, but you make a silly little error like you just made there, and you're not going to get the right answer. So z is equal to 5. So you got z equal to 5, y equal to 4, and x equal to 3. And that is the only method I really know how to solve well, there's some other methods, but this is the easiest one, where you have 3 equations and 3 unknowns. You have to pick a variable and eliminate it to get equation 4. You have to eliminate the same variable to get equation 5. In other words, it doesn't do any good if equations 4 and 5 don't have the same 2 variables. If I've still got an x, a y, and a z, by the time I get to 4 and 5, I've made a mistake. Because unless you can narrow it down to 2 equations and 2 variables, you know how to solve that. But if you have 2 equations and 3 variables, you can't go anywhere. So that's the key. And then once you get two equations, two variables, you can use just standard method to solve for both of those, and then go back and find an equation that allows you to solve for the third variable. Okay? All right, we have 5 minutes. What else? Okay. What method should we use to solve this? Yeah. What do you get when you use substitution? And what does that mean? That actually has a meaning here. Exactly. In other words, because minus 4 is never equal to minus 3, it means there's no solution to that. Now, notice what I could have gotten there a little quicker by using elimination, I think. What if I take that first equation and move the 2x over? That's all I'm going to do. I'm going to move the 2x over. So it gives you y minus 2x equals negative 4, right? Now you immediately see that there's no solution. There's no way y minus 2x could equal minus 3, while at the same time y minus 2x equals minus 4. That's immediate no solution, and it only really took one step. I just had to I tried to make that top equation number 1 look like y minus 2x, and I could see that all you got to do is subtract 2x to do it. All right. What else? Actually, why don't we end there? It gives me a couple of minutes to get into my next session. So anyway, Brandon, let me take a look at my calendar here. You can definitely do Thursday, but I thought your test was on Thursday. Oh, great. Let's do Thursday for sure. Because I'm really almost booked up on Wednesday. But what time on Thursday would you like? What time on Thursday? Brandon, what time on Thursday? Well, yeah, I can do 6:30 to 7:30. Perfect, actually. No, I'll do it right now. In other words, that's why I usually ask, is because it's easier for me to do than it is for you. Okay. No. I can take away this block. Can you do here? Okay. What time would you like to do? Two o'clock I can do. Let's do 2 o'clock. We'll do from 2 to 3 on Thursday. Okay? Perfect. I'll talk to you then. Okay, bye-bye.